Good morning, students. Today in science, we will continue the explanation of chapter 6, combustion and flame. Let's start with flame. Students, observe and let me know the color of an LPG flame and a candle flame. Yes, candle flame looks yellow in color, whereas the LPG flame is blue in color. Why is it so, students? Okay. Color of the flame depends on the oxygen supply. If oxygen supply is less, the flame will appear yellow due to incomplete combustion of fuel. And if oxygen supply is more or sufficient, then the flame will appear blue due to complete combustion of fuel. Now let's know how does this flame forms. Let's take the example of candle. When we burn a candle with matchstick, due to heat the wax melt. And this molten wax, that is the liquid wax, travels through the wick and gets vaporized and burn in presence of oxygen to produce flame. Students, remember, in combustion the substance that vaporize only are going to produce a flame. Means while combustion, the substance which get vaporized, they are going to produce the flame. Otherwise, no. For example, kerosene oil and molten wax rises through wick as they are liquid in nature, okay, and are vaporized during burning and form flames. Whereas when you will observe charcoal, it doesn't vaporize and so does not produce flame. Next, structure of flame. A flame consists of three zones, means three parts. These are innermost zone, middle zone and outermost zone. Let's deal with one by one. The innermost zone of a flame, it is also called the dark zone as it is black in color. This zone consists of hot unburnt vapors of the combustible material. As vapors doesn't burn in this zone, that's why it is least hot in nature. Okay, so this is the least hot part of the flame. Next is the middle zone of the flame. It looks yellow in color. The wax vapor starts burning in this region and so the color of the flame is yellow. Since oxygen available in this part is not sufficient for wax vapors to burn completely and therefore the temperature in this region is not very hot. This zone is also known as luminous zone as the light produces in this zone only. The next zone is the outermost zone. This zone looks blue in color. It is also known as non-luminous zone as it doesn't produce much light. Okay. Now here as it looks blue in color, so what does it tells? That complete combustion of fuel takes place here as sufficient supply of oxygen is there. And as complete combustion takes place, so the temperature is also very high in this region. So this is the hottest part of the flame. Now we will deal with certain activities to get more clear with the concept of all these three zones of the flame. So our first activity is to show that the innermost zone of a candle flame consists of unburnt wax vapors. For this, what you have to do, take a wax candle, fix it on the table and light it with a matchstick. After lighting the matchstick, hold a thin glass tube with a pair of tongs and introduce one end of that glass tube in the innermost zone, that is the dark zone of the candle flame. Now bring the lighted matchstick, means again light a matchstick and bring it near the other end of the glass tube and observe it carefully. You will find that that other end of the glass tube also catches fire. Now how this happen? See, the innermost zone of candle flame near that wick, it consists of what? Yes, unburnt wax vapors. Now some of these wax vapors enter the glass tube. Remember where we introduced that glass tube? In the dark zone. So that wax vapors travels through that glass tube and it travels means it passes through the glass tube and obviously it is going to move out from the other end. So when you brought the matchstick, lighted matchstick at other end, these wax vapors, it catches the fire and start burning a flame. Okay. So this activities proves that yes, the innermost zone of a candle consists of unburnt wax vapors. Now the next activity to show that the middle zone of candle flame consists of unburnt carbon particles. I told you that incomplete combustion takes place in the middle zone. So again you have to light a candle, but this time you have to put a glass slide with the help of a tongue. Put the glass slide in the middle zone or the luminous zone of the flame. Hold it for some time, just for about 10 to 15 seconds. Then remove and observe it carefully. You will find a blackish ring is formed on the glass plate. This blackish ring is produced due to deposition of unburnt carbon particles present in the luminous zone of the flame. Now, the third activity to show that the outermost zone, that is the non-luminous zone of a flame, is the hottest part of the flame. Okay. Now to prove this, what you have to do, take a long copper wire and again hold it with the piece of a pair of a tongue and introduce one of the end of copper wire in the burning candle. And in which region? Yes, the outermost zone of the flame. And just observe, keep that wire in that zone for some time, 30 to 40 seconds. Okay. Then observe it. You will find that the copper wire becomes, that part of copper wire which is introduced in the flame, it becomes red hot. So this tells us that yes, the outermost zone that is the non-luminous zone of the flame having the highest temperature. So this was all about candle flame and its structure. Next we will deal with the topic fuel and its efficiency. What is fuel? You already learned so many times. Okay, so how you are going to define fuel? A material which is burned to produce heat is called a fuel. For example, wood, coal, LPG, petrol, diesel, charcoal, cow dung, all these are different examples. Okay. Now, the heat energy produced by burning fuels is used for domestic and industrial purposes. All of you very well aware of this fact. But children, all fuel does not burn efficiently. Means on burning they do not produce same amount of heat. Thus, the efficiency of fuel is expressed in terms of its calorific value. Calorific value means the heat value, how much amount of heat that fuel is going to, on burning, that fuel will produce. That will be called as its calorific value of that fuel. So how you are going to define calorific value? The amount of heat produced by complete burning of 1 kg of a fuel is called its calorific value, and the unit in which we will express this calorific value is kilojoule per kg. Children, as much amount of energy that fuel on burning will produce, as much efficient that fuel is going to be get considered. See, the calorific values of some of the common fuels are given in this chart. You can go through it. That you will find that hydrogen gas is having the highest calorific value, whereas the cow dung cakes, they are having the lowest calorific value among these whatever is mentioned in the table. Okay. Children, we are having so many fuels, okay, with us or in our surrounding, natural or whatever. So all these fuels are not having same characteristics. There are certain characteristics of an ideal fuel. Ideal fuel means or a good fuel. So what are they? A good fuel should be cheap, readily available and easy to transport. It has a high calorific value. That is, it produces a large amount of heat on burning. Okay. It burns easily in air at a moderate rate. That is, it burns neither too fast nor too slow. It has a proper ignition temperature. Ignition temperature, you already learned that. It should be neither very low nor very high. The ignition temperature of that fuel should be proper. It does not produce any harmful gases or leaves behind any residue after burning, which may pollute the environment. So all these features are the characteristics of a good fuel. Now students, burning of fuel is not only beneficial for the human beings. There are certain harmful effects also. Now what are the harmful effects of burning of fuel? Air pollution is caused by the unburned carbon particles released from the burning of fuels like wood, coal and petroleum. Okay, and these can cause many respiratory diseases among human beings. Another harmful effect is Incomplete combustion of fuels produces a very poisonous gas called carbon monoxide. And when incomplete combustion will takes place, obviously when there will be not sufficient supply of air will be there. It is advised never to sleep in closed room with burning coal fire in it, as combustion of coal will be incomplete due to less oxygen, and which will result in release of poisonous carbon monoxide gas, which can kill the person sleeping in that room. So one should not sleep in a room where we are burning coal. Okay. Next, another harmful effect. Students, you all are aware of global warming, which is caused due to increased concentration of carbon dioxide in air. That releases, and that carbon dioxide from where it comes, that also is going to release due to combustion of fuel. And if the global warming will be there, means temperature increase of environment will be there, it will have many other after effects, like it will lead to increase in earth's temperature, due to which what will happen, the polar ice melts, raising the sea level, and it will result in flooding in low-lying areas. Now another harmful effect of burning fuel is acid rain. See, oxides of sulfur and nitrogen produced by the burning of coal, diesel and petrol causes acid rain, which is harmful for human beings also, like as it damages the skins, then crops also, and buildings and soil. It damages everything. Okay. All these effects are due to burning of these petroleum fossil fuels or wood or else. Okay. So we can try to reduce it by the use of CNG in cars and buses, which is a cleaner fuel. I hope the basic concepts of everything in the chapter is clear to you.